All right, so now we're on step 6 of 3.4. So step 6 is to look at the possible points of inflection is what we're looking at, right? And to determine concavity. So in this part, I might call it POI again for short, possible point or points, right, of inflection. And we're talking about concavity, and that's going to help us with our sketch as well. So if I write down what my first derivative was there from the previous question, I ended up with, before I set it equal to 0 there, was negative x minus 2 all over x minus 2 cubed. And then what I want to do is I have to, in order to do points of inflection, I need the second derivative, right? So the second derivative is, again, quotient rule. I'm just going to write, actually, I might not even, might need that room over there. So I'm just going to say, I'm going to use the quotient rule, same thing, right? I have a numerator and denominator. So that quotient rule is, again, the derivative of the top. So the derivative of the top is negative 1 times exactly what the bottom is, x minus 2 cubed minus, so that's the first part, the derivative of the bottom. So the 3 going in front, x minus 2 squared, but then don't forget I have to get the derivative of the inside, which in this case is just 1, which is nice. And then I have to multiply it by the top. So negative x minus 2, right? And then again, the bottom, the x minus 2 cubed in square brackets squared, whatever the denominator is squared. Now it's just a matter of cleaning everything up, right? Which could take some time. So I have here, let's see. I'm just looking. I think in my notes I left out the negative at first, but my line after that had it. So I end up with here negative x minus 2 cubed. And then here I would have, again, negative 3, basically just times 1. Everything else is in brackets there. So then just negative 3. I'm really just getting rid of actually writing down the number ones, and that's it for this step. X minus 2 squared, and then negative x minus 2, and then just cleaning up the denominator to be x minus 2, right, to the exponent of 6, because I'm multiplying those. And then what could I have here? I have, if I take a look, I have a common, I have x minus 2 to the exponent of 3, and I have x minus 2 to the exponent of 2. Now this is not the same, right? Because this x is positive, this is negative, this is a negative 2. This is a negative 2, but it's not exactly the same because the x is negative. But I can take out a common x minus 2 squared. So this negative out in front, if I just left it out in front and factored it out as well, x minus 2 squared. Then I put square brackets to indicate what's left over. So I had 3, I took out 2, I'm left with 1, x minus 2 to the exponent of 1, right? And then a negative times a what will get me back to a negative. So that inside the bracket would be positive. I didn't take out a number, so the 3 is still there. This is gone, so it's just 3 times negative x minus 2, right? And then close my square bracket and then copy out the denominator, x minus 2 to the power of 6. Okay, so now I can clean up inside the bracket. So I'm going to copy out this part, the negative x minus 2 squared. And then I can just put regular brackets. So I have, again, here, just in a different color, I have x minus 2, and then here multiplying in, right, distributive property, negative 3x, and then negative 6, right? So in the brackets, I would have x minus 3x, which would be negative 2x minus 8. Okay, all over my denominator. Okay, now what? X minus 2, 2 of them. X minus 2, 6 of them. So I could get rid of 2 of them and I'd be left with 4, right? I have to leave that negative there, don't forget. That wasn't common. That didn't get rid of. So I have a negative bracket, negative 2x minus 8. This is gone all over, at least a little bit less. X minus 2 now to the power of 4. And then it's really up to you. There's a couple different ways you could write this. I'm going to bring the negative into the bracket and basically do distributive property. So I would end up with a positive 2x and then a positive 8, which just is nicer, right? You don't have those negatives there over the denominator of x minus 2 to the power of 4. And then we've got our second derivative. So this is our final second derivative. We're going to set that equal to 0, right? So again, just here I am here. I'm just moving it back up here and setting it equal to 0. So if 0 equals the 2x plus 8 over x minus 2 to the power of 4, again, same thing. If I was to cross multiply, I'm really ending up with 0 equaling the numerator, which is nice. If I were to bring that 8 over to the other side, I'd have negative 8. And then divide by 2, I'd be left with x equaling negative 4. So x equaling negative 4 is a possible point of inflection, right? So let's write that down. So let's write that down, underneath here. Therefore, I have a possible, we don't know yet till we do the chart, the second derivative test. POI, I'm going to say, I have a possible point of inflection at x equals negative 4. Might be where it changes from concave up to concave down, right? We're not really sure yet. So, so let's do I'm just looking, I'm not going to have room for the chart, but I can do the number line here. So again, this is my x-axis. This is positive infinity. This is negative infinity. I put a value on x of negative 4, but again, this is my x-axis. My x-axis still has my vertical asymptote at 2, so I still need to add that in. And then just label so I don't forget that that is not a critical point or a point of inflection, right? That's a vertical asymptote. Now this is I could say POI, point of inflection, but we don't know for sure it's possible. So I guess we'll say POI for now until we do the chart to figure out for sure. So my chart has 1 interval, 2 interval, 3 intervals, which means it's going to have 4 columns. And I'm going to have to move this onto another page, right? So again, as long as you have the number line near you, we can use that number line to continue on with the chart. If you can, I would try to fit it onto the second page. That is the second page, right? No, well, technically the third page. If you need to fit it onto the 4th page, I would just rate it pretty small if you can, because I don't have it on the last page and I had a little bit of room left over, but not a lot. So factors of my second derivative, f double prime of x. And then for my x-axis intervals there, I had from negative infinity to negative 4, right? My possible point of inflection was at negative 4. Then I'm between negative 4 and 2, my vertical asymptote. And then I'm going between 2 and positive infinity. Then I go down to, I think I put a star beside it this time, what my second derivative was. So again, just to write that down, where do I have it here? Before I set it equal to 0, here I've got a star beside it. It was 2x plus 8 over x minus 2 to the power of 4. So then my factors of the second derivative would be the numerator. 2x plus 8 would be 1, and then the denominator would be another, right? X minus 2 to an even degree exponent. And then I have my overall sign of the second derivative. Make sure there's 2 there. I need a little bit more room. Now this is telling me if it's concave up or down, right, over the original function. So concave up or down along f of x. All right, let's do this chart. Between negative, after -4, -5 then. 2 times -5, -10 plus 8 is still going to be negative, right? -5 minus 7, but then to exponent of 4 would be positive. This is dividing. So I have a negative divided by a positive, still going to give me negative. So negative means I'm concave down there, right? Any number between -4 and 2, 0 is in there. 0 is always nice. That'd be 0 plus 8, positive. 0 minus 2, but -2 to a positive exponent would be positive. So a positive divided by a positive is positive. So I am concave up here along this interval, and between 2 and infinity, pick 3. 6 plus 8 is going to be positive. 3 minus 2 is a positive 1. So that's positive. Positive divided by a positive is positive. And here I'm concave up. So again, I have 2 concave ups beside each other, which unless you did the work here, you might have thought it was every other. But again, we've seen many examples now where it's not, where I actually have to do the work. So what am I finding here? So here I'm concave down. So I'm going like this, concave down, and then I'm switching to concave up, which means that there is a point of inflection. So right here, again, I'm just going to use that for short. There is a POI then I have found at x equals -4. Now be careful here at 2. I know the number line isn't visually in front of us, but it should be hopefully in front of you. That's a vertical asymptote, right? That's not a possible point of inflection at x equals +2. So if I have a point of inflection at, instead of equals, I wanted to say at, point of inflection at x equals -4, then I need to plug it into the original. So again, you might want to write the original out here somewhere. Where's my original? X over here, f of x equals x over x minus 2, and that one is squared. So f at -4 is a -4 on top over a -4 minus 2 squared on the bottom would be -4 over -6 times -6. And does 4 and 36 combine into something nice? 4 divided by 4 and 36 divided by -4 ends up with a -1/9. So therefore, my point of inflection is at -4 and -1/9. Okay, so that's done step number 6. So we're pretty much on sketching now. I just have to put some conclusions here. I haven't listed when I'm concave up or down, right? So f of x is, if we want to say concave down first, the original function is concave down when X is less than -4, right? And it's concave up when, and it's concave up between this interval and in this interval, but I do have a vertical asymptote, so I probably want to list those two separately, right? So that I'm concave up when I'm between, X is between -4 and 2, and when X is greater than 2, because at that exact value of 2, I have a vertical asymptote. Now I can graph. So now I'm going to move it to the very final page there, and I'm going to list in conclusion, and you guys should too, all the information that you just figured out so that it's right there beside the graph for you to graph. So let's go to the next page. All right, let's see if I can fit everything in here. So in conclusion, I want to list all my points. So I had, I was going to do X and Y intercepts, but sure, we can do the vertical asymptotes. And so I have a vertical asymptote at X equals 2. I have a horizontal asymptote, remember, at Y equals 0 on the first page if we look at that. I have an X and Y intercept are the same. 0, 0, so the same point there. I, from the first chart, have a local minimum at -2 and -1/8. And so if you wanted to change that into a decimal, just to kind of, that would be -0.125. And I have a point, 1 point of inflection at -4. And then you kind of take a look at all of your X values and all your Y values to determine how you're going to be graphing this and where you put your axes, right? And -1/9. And -9 is also a small number just to the left of 0. We're at -0.11111 repeated. So if we look at this point of inflection at -4, looking at the second graph there, it's concave down all the way until I get to -4, and then it's concave up, right? So it's concave down before that point, and then it's concave up. I'm looking at my second derivative chart, the one I just did. So to start graphing, let's do our asymptotes first. So again, they are imaginary, but we should still put them in because it's going to help us when we're graphing, right? And to see everything on the page. So in terms of where do I put my X and Y axes? For my X values, I have a vertical asymptote at 2, then I have a 0, a -2, and a -4. So there's not a lot going on. The numbers are not very big. Basically, my Y-axis could be somewhat in the middle, right? Now, if I take a look at my Y values, I have 0, 0, 0, negative just past 0, and negative just past 0. So I have a lot going on just right around 0 and just underneath 0. So I could move my X-axis up a little bit if I wanted to, because there's not a lot happening above it. But I also could fit it because it is so just beyond 0, just below. I could just kind of do everything centrally too. It doesn't really matter either way. I'll do a thicker line here. So let's put in, I said my X numbers were just hovering around 0. So my Y axis there could be in the middle. And if I put my X just a tiny bit positive and label, this is my Y axis and this is my X axis, but I also have to do, so my X axis, I can just have a scale of 1, right? 1, 2, 3, 4, -1, -2, -3, -4. But if I want to include these, like, how do I include these decimals, right? How do I graph -2 and -0.125 and -0.1? I could actually go, and I have the room to do every other space is 0.1. So I have -0.1 here, skip a space, -0.2, -0.3, and again here, +0.1 and +0.2, but nothing's going up that high anyways. And so, like I said, let's do our asymptotes first. I'm going to do them dotted, so it's kind of hard for me to do it drawing a line. I'm just going to do it freehand. Hoping you can see this. So my vertical asymptote at x equals 2, find x equals 2 and just do like a dotted. Yeah, that's not really showing up very much, but I don't know if the neon green, you can see that from the video. So I'll have both in there. Anyway, so that's all the way from the top to the bottom is my vertical asymptote. And then I have a horizontal asymptote right here at y equals 0. So y equaling 0 is right along the x-axis, but I still want to include it. So again, this is where I say you always want to have different colors, because then I could put another color laying on top of it. And I would be able to see that when I'm marking you. And then you can indicate that that's your horizontal asymptote, so I can see that as well. So my vertical asymptote is at x equals 2 to label that, and my horizontal asymptote is at y equals 0. So even you could say these two are done. Okay, so then for my points, I don't know, I could do this any color. If we do it red, hopefully that's easy to see. X and Y intercept, basically I just have a whole bunch of stuff going on there at 0, 0, right? So that's taking care of that one and that one. Then I have a local minimum at -2 for x. So over on this side, -2, and then be careful, just past -0.1. So this is -0.1. I'm not at -0.2. So halfway in between would be -1.5, and it's 1.25. So I'm just a quarter of, or halfway down in between the first. So again, in between is 1.5. So I'm going to go exactly in between this grid line and the next grid line. And that is my minimum. So if it's a minimum, it's going to be right coming up, kind of drawing that in there on either side there. It's going to be coming up. It's going to be concave up there, which I will double check from the chart. But yes, that makes sense. And then I have my point. I also have my point of inflection at -4, and exactly pretty much, well, not exactly at -0.1, but we're talking so little below it that you're basically still touching that -0.1 line. Okay, and that one is done. And what's happening there? So if I go back to my second chart, like I said, I was concave down until I reached -4. And here's my horizontal asymptote, so I'm not going above that, right? So I'm concave down like this, just to kind of trace that in. And then I'm going to be concave up. So if I'm concave down, and then I'm going to be concave up here, and that makes sense for my minimum. And then I'm up here to this point. So there we go. I'm going like that, going like that. I'm going to be concave down and approaching, concave down here and approaching 0. Should be flattening out. I shouldn't be going back down there. Should be flattening out. And then back up until I reach the vertical asymptote here again, but not touching technically the vertical asymptote. Okay, so what do I need to write down here? I added the minimum. I should maybe add here that this is my point of inflection. So I've got my point of inflection. I've got my minimum. I can also see on the graph here that that's the lowest point that the graph will ever reach. So this is also an absolute minimum. You don't really have to write that out, but it's also an absolute minimum. From my first chart, I haven't looked at my first chart yet. My first chart was saying between negative infinity to -2, this point here, I'm decreasing. And if you can see, my graph is going down all the way to -2. And then after that, I'm increasing to 2. So I'm increasing to 2. But then if you go there, I'm also decreasing after 2. I'm decreasing after 2. So there's more of the graph there that I need to be drawing, right? If I'm decreasing after 2, go back to your first chart. So then I need to just draw in here the rest of my graph, right? A vertical asymptote and a horizontal asymptote there. So I can't go beyond the horizontal asymptote of y = 0. So here I am, just to state here, decreasing. This is along the first derivative chart. So if I look along the first derivative chart, I was decreasing. Here I'm increasing. Here I'm increasing after 2. So this section here I'm increasing. This section here I'm decreasing. Also this section here I was concave down. This section here I'm concave up. And in the second chart we have concave up beyond 2 as well, which you can see here. It looks like it's concave up, right? It's half of a smile there as well. And what else did I want to mention? There was something else I was thinking of. Well, we have to do the domain and range, but we also have to list our limits we don't have written down here, right? So here are, as x is approaching 2 from the left, as x is approaching 2 from the left, y is going to be reaching positive at infinity. Where do I have my final statements there? And I'm reaching positive infinity as x is approaching 2 from the right. Oh, 2. Here I'm at -2. So 2 from the left, I'm reaching positive infinity. So I have basically like arrows going like this, right? Which is what this is connecting to here, basically. And for my horizontal asymptote, I said as x is reaching -infinity this way, I'm approaching 0, but from the bottom. So again, that's why I'm not going past 0 on the top. I'm approaching from the bottom. And as x is approaching positive infinity, y is approaching 0, but from above, which is why this is going to get closer and closer and closer, right, to x, but never actually touch it, and I'm going from above. So I have already technically included that on the graph. So then let's just do our domain and range. And we're done. So my domain, I know that x belongs to the set of real numbers because I have a continuous solid line here. There's no breaks, there's no open circles or anything like that. It basically would continue to the left. It's going to continue to the right. I just have this break here from the vertical asymptote. So I just need to include there that x cannot equal 2 only, because that's where my vertical asymptote is, right? And for my range, take a look, y belonging to the set of real numbers. Y is going to continue on positive, y is going to continue on here, but it's actually never going to get less than negative 0.125 or -1/8, right? So I'd have to say that y is greater than or equal to -1/8. So if you take a look, just like we said in step 1, I do have the graph, if you look at the red graph here, going through the horizontal asymptote. So there's my horizontal asymptote. And it said that I can have that happen if you go back to the bullets on the first page. So I have my graph going through the horizontal asymptote of y = 0, because I can see that that point, exactly 0, 0, that point 0, 0 laying on the horizontal asymptote, it exists. It's a closed circle there, right? But the vertical asymptote, I'm not crossing.